review what we've done quickly with arithmetic and geometric sequences and series. And then we're going to have time together to catch up on assignments from this week. So far, all we've done for mastery tests are arithmetic sequences in series. And then today is the first day that I'm like assigning geometric sequences in series. Savannah pointed out it's not the very first mastery test. I'm skipping that for now, and we're going to come back to that at the end of the unit. Okay, I wanted to start with arithmetic and geometric sequences in series. So that's what we did on Monday and on Tuesday and yesterday. So let's get a little bit of practice. Get your notes ready. I want to just do a quick chat quiz with you. It's not going to count for a credit, but it's a review over these topics: arithmetic, geometric, sequences, and series. So in the chat, answer these for me. Do the best you can. We'll probably just do 10 seconds per question. In your own words, how do arithmetic sequences increase or decrease? And you can just type it in the chat. How do arithmetic sequences increase or decrease? There's many ways to say it. I'm not looking for like the right way to say it, but in your own words, how do you think about it? What do you remember from this week, or what do you have in your notes? How do we know that it's arithmetic? How do they increase or decrease? There's a certain way they do it, because they can get bigger. They can increase or they can get smaller in their list of numbers, but they always do it a certain way. If it's arithmetic, it's the same way over and over again. And that's what I was asking. That's what I'm trying to ask now. All right, I see 3 responses in the chat. Thank you to people who are answering. Let's see, there's 8 people in the call. So that means there's 7 of you folks in class with me. So this is what we've been doing all week. You should have some idea of what arithmetic sequences are and then how they increase or decrease. Okay. Xavier, Savannah, and Tatiana. Anaya, thank you. Tira. Okay, good. I'm seeing a lot of good answers in the chat. Thank you guys for answering. I do want to. Oh, go ahead. Someone's talking.
I was going to say that how they increase or decrease. Sorry, I wasn't going to explain how they increase or decrease. I was going to explain how they how you can tell that they increase or decrease, and that's by the pattern that they have.
Totally. By the pattern. Thank you, Levi. Pattern. And then in the chat, I'm just going to kind of summarize a lot of what I saw many people were saying in different ways. I saw people saying addition and subtraction. That addition or subtraction is the pattern. Someone said by their number. You're correct. I just want to be clear. It's addition or subtraction, a pattern of addition or subtraction. So if it keeps going up, I'm not going to even make up a number example, but if we've got our sequence listed here and we see that it's going up 5 and then plus 5 and then plus 5, we are adding 5 each time. So that means it's an arithmetic sequence. Likewise, it could be going down a number each time too, and that's okay. That just means it's decreasing. Maybe it's going down one, down one, down one, and so forth. So that's how the arithmetic sequences increase or decrease, by adding the same number or by subtracting the same number in that pattern over and over and over and over again. So now, what do we know then if arithmetic goes with just addition or subtraction? Question 2 is, how do geometric sequences increase or decrease? Can they also go up and down by addition or subtraction? Or are they strictly another way? Is it addition and subtraction, or is it multiplication and division? Take a few moments, type in your best guess, your best idea of how to explain that in your own words. So first question was arithmetic, and those are just addition or subtraction. So then how do geometric sequences increase or decrease? I see 3 of you have answered. I'm going to hold off for a second. I want to hear from really all 7 of you. How do we know if it's geometric? How are they going up or down? Thank you to the people who have answered. Let's be patient and give other folks a chance to answer too. We're almost ready. Okay, I'm just going to do a quick scan to see who's Levi. Thank you. And Tira, Tatiana, Anaya, Savannah. High five. Thank you, guys. And I'm seeing a lot of the keywords I was hoping to see as well. And Savannah, awesome. Good. Multiply or divide by the same number. Savannah just added that in. By the same number? Yes. So these are going up by multiplication. Sorry for my spelling. Multiplication or division. By the same number each time. That's their pattern. So geometric sequences, let's say we had them listed out here. These are empty spaces, just for example. You're timesing some same number over and over again. Timesing by 5. Times by 5. Times by 5. For example. Or maybe we have a division one, where it looks like we're dividing by 2, dividing by 2, dividing by 2. Now, if it is a division one, when we use our formulas, just remember in the formula for geometric sequences or series, the number r shows up. That's the common ratio. And that will be stated as what's being multiplied. So if it's a division one, like divide by 2, the common ratio here is 1 over 2 as a half. We can't plug in 2 for our r because it's going to think in the formula that you're doing times 2, times 2. So we would do times a half to signify that we're dividing by 2. That's what we get when we multiply by a fraction. We're dividing by the bottom number. Okay, and then I wanted to quiz you really quick on some of the formulas that we've used this week. So here's a formula. Which formula is this? Is this the geometric or arithmetic? And is it sequence or is it series? We had 4 formulas from this week. So it could be one of those 4. Look at your notes, or if you already know it, type your answer in the chat for me, please. Is this the geometric or is it arithmetic? And is it sequence or is it series? It's one of those 4. It's either going to be arithmetic sequence or arithmetic series, or it's the geometric sequence, geometric series. Just to be clear. Sorry about that. Hope that made sense. All right, I see 3 responses. Thank you, folks. Check your notes, or if you have a feeling you remember it, go ahead and type in what you're thinking. Okay, let's see who's answered. Anaya, Levi, and Savannah. Thank you, 3, for answering. I appreciate you trying. All of our formulas, someone else answered. Tatiana, thank you. All of our formulas we saw this week, there's going to be a lot of familiar looking parts. I think they all have A1 in them, or yeah, every single one of our formulas has A1. So that's going to look familiar. But some key parts that we can use to help distinguish is if does it have a D in it or does it have R in it? The if it has an R right here, that's the common ratio, and that means we're dealing with a geometric formula. Whether it's sequence or series, we know for sure it's geometric. If it has the R, that's should be a clue that it's going to be one of the geometric ones. Um, so this one is geometric sequence. Remember what AN means? A sub n in the beginning? That means the number from the list. So if we were plugging in and solving for AN, like this geometric sequence formula, it's going to tell us the nth number in the list. So we would have to know our common ratio. We'd have to know our first term, A1, and then we're plugging in a number for n, which is that place in the list. So if I want the 10th number, I plug in 10 for n. If I want the 50th number, you plug in 50 for n. And then it gives you that 10th or 50th number in the list. Okay, one more. What's this formula? This time it has a 1, it has D, and it's also an A sub n formula. So that's a clue that this is a sequence formula, but is it, what kind of sequence is it? Okay. Awesome. Anaya, Savannah, thank you too. Arithmetic sequence. So this is the very first one we did on Monday. Antira, thank you. Good, good. And good reasoning too. Doesn't have the R. So if it doesn't have R, it's going to be arithmetic. That's a good way to think about it. Both of our arithmetic, I'm sorry, both of the geometric, the multiplying, dividing formulas have R in it. Okay, I just wanted to quickly review some of the basics from this week, try to put it all together. And now it is 11:20. Why don't we do like 2 examples from the mastery test for geometric? And then I want to use the rest of our time today as a work day for you to catch up on your homework for this week. And then if you have questions while you're doing your mastery test, we can do it together. So once we're done with our examples, I'm going to do 2 examples with you from the mastery test. Then I can do breakout rooms if you want to work like by yourself. Or you don't have to go to the breakout room. You can stay in the main room. And then you can tell me if you want to go over a problem together. All right. And I think we did Mr. Brown and his television already. Let's try this one. What is the 33rd term of this arithmetic sequence? They want to know what is the 33rd number And they're telling us, this is nice, they're telling us it's arithmetic. We should be able to figure out, though, just by looking at the sequence itself, if it's geometric or arithmetic. We have to ask ourselves, is this going up or down by adding, subtracting, or is this going up and down by multiplying, dividing? And that's how we know which type of sequence it is. Then we have to use the correct formula. We're supposed to find the 33rd term from the sequence. They're not asking us to add up the terms. So we're not using the series. We're going to use the arithmetic sequence formula. So we need to find the common difference, and we need to find A1. We're going to plug those in for A1 and D, and then we're going to plug in 33 for N. You all see the first term. That's the first thing to start with because it's given to us. So the first term here is 12. It's the first number from our list. We need D. And then N is going to be 33 because we want the 33rd number. Let's see in the chat. -5. Thank you, Anaya. It looks good. Let's double check. I always like to, once I find it myself, I'm going to check all the terms if they give us a list like this, just to make sure. 12 minus 5 gets me 7. Good. 7 minus 5 is 2. 2 going down 5 spaces should give me -3. That's correct. And then -3 minus 5, -8. So D is -5. Good job. So now we're ready. Because it's a -5, I'm going to clean up my formula a little bit. And instead of doing plus a negative number, I'm going to say -5. So now we're ready. Do the parentheses first. Then we multiply. Then do 12 minus that answer. Try that on your own. And if you can, I want you to put your answer in the chat. Just try it out on your own. It's okay if you don't get it right the first time, but take a risk. You can type your chat just to me, so you don't have to share it with the group. That's all good. I just want you to try it. And I'll try it myself, and then we'll all look at each other's notes here. Or, we'll compare notes. 33 minus 1. Okay, 3 of you have answered, or there's 3 responses at least. Thank you, guys. Those of you who haven't answered yet, keep trying it. It's 3 steps. First, N minus 1. It's 33 minus 1. You can do that. Then times that number by 5. And then you're going to do 12 minus that product. All right, just want to see who tried. Tira and Anaya and Savannah, thank you, you guys, you 3. Let's work it out really quick together. (33 minus 1, 32. 5 times 32, 160. Don't forget the last step is A1 minus that product. So 12 minus 160. Negative 148. That means the 33rd number is negative 148. Those 4 equations that we ended yesterday with, I printed it up myself for my own notes. These four equations are basically all we're going to need to do all the problems you could get on this mastery test. So comment in the chat. Nice. Good job, Tatiana. And so it is important, though, that we know which one to use, right? This is just asking us which number in the list, what is the 33rd number term? So that means we're using one of our sequence formulas. If they're asking us to add up something like Mr. Brown's television, this one, we did this in class, I think on Tuesday. How much will the television cost him? Well, they're not asking for a single number in their list. They're asking us for like, what is the sum of all the months he paid? So we had to figure out the R or the D and then plug it into the correct series formula. And then we could find the sum of all those terms in the list. So we're going to have to figure out which formula to use. I think we did Anna already. We did this on Tuesday. Here we go. Let's do this as a group. What is the sum of the first 28 terms of this arithmetic sequence? All right, cool. So they're telling us it's arithmetic, and they're also telling us they want the sum. So that means we're going to use the series formula. That means if we plug in all the right parts, it adds up all the terms for us up to n of 28. The first 28 terms. So series formula, find that in your notes. From yesterday, we found it was this. So Sn, that means sum or series. Okay, so here's our series formula. Notice though that in the formula is a sub n. We need a sub n to use our formula. So that means we're going to have to start with the a sub n formula in order to get that 28th term. We want to know what is the 28th number because that goes right here. 28th term. So we need to do that first, and then we can back up and do our series formula to find what their sum is of all 28 numbers. So first term is 69. Common difference, what's it going up or down by? What is D? Thank you, Anaya. I agree. That's what I found too, plus 6. 69 to 75. You can count from one to the next. You can subtract 75 minus the one before it, and then you'll get positive 6 for our D this time. Now look at the formula I've got so far. I plugged in N28. Let's go to town. 28 minus 1 is 27. 6 times 27, I don't know. Let's find out. 162. And then add that to 69. Don't forget to do that last step is we have to combine it with A1. So 69 plus 162, 231. Woohoo! So A28 is 231. That's the 28th number in our list if we keep adding 6 each time to this list. Okay, now I'm going to partition this. Nice job, Tira. I see that. Thank you. Good. Now remember, They're asking us for the series, though, the sum of the first 28. So that was side work. We had to do that background work to use our series formula. So now we'll do that on the right. So how you would write this is series first 28. So that's why this little 28 is there. But then what's important is the stuff on the right of the formula. So this guy, I'm going to write it blank again so you see what I'm doing. Same formula, but let's plug in all of our parts. So now n is 28, a1 is 69, an is 231. We needed that. We just found it. And then all of it divided by 2. All right, again, do the parentheses first. So add those two guys up and then times it by 28 and then divide by 2. So 69 plus 231. 300 even. Nice. Okay, 300 times 28, going to be huge. 8,400. All right, divide by 2. 4,200. 4,200. If you're worried and hesitant about like filling in the formula and then trying to simplify it, just keep in mind we always do parentheses first. And in our formulas, they're all going to be just like one thing minus another thing or one thing added to another thing. For the geometric series, though, we do have to do an exponent first. So then exponent inside, then the adding or subtracting. Multiply the two numbers on top. So that's where we did that right here, 28 times 300. And then last step is divide by whatever's in the bottom. So one step at a time. Nice job, Tira. We got the same thing. Thank you. Maybe we should do a geometric problem. Okay, I saw this one for the geometric. And this is weird. This was the very first problem in the geometric mastery test. And the format is all weird on these answers. It's terrible. This is a mistake. It's not meant to look this way. So let me try to clean each one of these up. So what this is saying is an is equal to 24 times 6 to the n minus 1. This one is an equals 2/3 times 6 to the n minus 1. This one is a sub n is equal to 24 times 6 to the n. And then last we have an 3/2 times 6 to the n minus 1. Excuse me. They want us to pick the right formula to go with the information above given. What is the nth term of the geometric sequence that is a common ratio of 6 and 24 is its third term? Third. Pay attention. Not first term, third. So we had a problem like this where we were given information about the third term before. We have to like work backward to find its first term because the formula for the geometric sequence is this. An equals a sub 1, first term, we need that, times r to the n minus 1. So basically, our question is going to be, is the first term, a1, is that 24? Is it 2/3? Is it 24? Or is it 3/2? So how do we find out? I'm going to set up one of these, a blank sequence, because that's how we best like to work with these, I think. That's how I do, because then we can see that difference or a ratio better. They told us the third term is 24, and the common ratio is 6. So if they're telling us the common ratio, r, is 6, that means we're timesing r. Remember, it's always set up as times the number. So it's times 6 to get further down our list. So 24 times 6 144. We'll just do a couple. 144 times 6, 864. And one more times 6, 5184. Huge. Okay, so you can see that what we have so far, and this is the third term and onward, what we've got going on so far, they're increasing. So we're going to divide by 6 going backwards then. So before 24, A2, what should that be? What's 24 divided by 6? Someone's got it already. 4. Thank you, Tira. And oops, now one more time. We have to divide by 6 to find A1. That's what we're looking for. This is tricky because, sorry, it gives us a fraction. What happened? Here we go. Good, Savannah. You see it also? 4. Now, remember, guys, going backwards. So 4 divided by 6, technically, it's 4/6. That's not one of the answers, though, is it, for A1 that we see? So if we reduce our fraction, nice. And as a decimal, it is. That's correct. As a decimal, it's 0.6. But as a fraction, which is how the answers are, if you look at option B or option D, that means it's either 2/3 or 3/2. So we know that it's 4/6, but if we reduce this guy, 4 divided by 2 is 2, 6 divided by 2 is 3. So what we found is that A1 is 2/3. And therefore, the formula would be 2/3, common ratio 6 to the n minus 1 power, boom. Option B. You know what? Yesterday, we didn't get to many examples at all of doing geometric stuff, did we? So I'm going to stop sharing quick. My plan was to like stop today and have you guys work on the mastery test. So I think I'd like to kind of do both, more examples and mastery test. So here's what I'd like to do. Anyone who feels ready to try the mastery test for geometric sequences series, I want you to start that mastery test. Or if you want to do more examples, then you can stay in this call and just take notes on what we're going to do. But then the homework is going to be for everybody to do mastery tests for geometric sequences series.
I'm going to stay in the call.
Okay. Thanks for telling me. Let's do a quick, like a vote, if you don't mind. We can do it in the chat. If you're feeling like you're ready and you want to leave, you don't want to stick around for this, let me know if you want to go straight to your mastery test, or do we want to stay in the call and do more examples? Thanks, Tatiana. I see that. So Tira and Tatiana, Anaya. Okay, thank you, 3. Let's just do some more examples. Not a lot of people are even voting. And that's the problem with America. Not everyone takes advantage of their vote. Let's, here, let me share my screen again. But I appreciate you 3 who did tell me. Sorry. Okay, so we'll do some more examples of geometric stuff, okay? This is just geometric problems. Okay, what is the common ratio of the geometric sequence whose second and fourth terms are 6 and 54? Interesting. So they're telling us this is the second term and the fourth term. They're asking us what is R? What is the common ratio? And we know it's a geometric sequence. That's good too. So we're not adding, subtracting, we're multiplying, dividing. So let's, like the last problem, start kind of a blank sequence. Fill in the parts we know. And see if we can figure out R. So they told us for sure that 6 is A2. That's the second term. And then 54 is A4. Now, interesting. We want to see what is A3, right? If we had A3, that would let us figure out the pattern. It's geometric, so we know we're multiplying something because it's getting bigger. 6 to something to 54. Any ideas? Any thoughts? How can we attack this and try to figure out what is R? What are we multiplying by? The same thing, of course, the same number each time. And what is that missing number in A3?
Do you like divide like backwards?
Ooh, nice. I like where you're going with that. If we divide 54 by 6, that might be a good start. What do we get? That is 9, correct? Check. Yes, thanks, Savannah. Okay, so I don't think that's R, but I think we could use this to find R because 54 divided by, let's do this. I'm going to write it as R. 54 divided by R is giving us 6. And we just did 54 divided by 6, and it's 9. Is there a number that when you multiply it to itself twice equals 9?
No.
Savannah? Savannah said in the chat, is that to everybody? No, it was just a direct message. Savannah remembered one from her past. There is one number we can do that with. Here's how we can solve for it if we don't remember it. The square root tells us what single number multiplies to itself makes the 9. So if you take the square root of 9, it comes out to 3. Now, that was a lot of extra special, maneuvering that we didn't necessarily learn in our 4 formulas, of course. But you all are prepared to set up a blank sequence like I started with. Fill in the parts they give you, the 6 and the 54. We know which place they go in. You also know that to go from 6 to A3 to A4, it's times R times R. So I hoped that we would be able to find that 9 like we did, because we know if we divide going backwards, we could find out, okay, 6 times something times something again is 54. Let's look at it another way. One more way to kind of look at a harder problem like this. We know that times R is happening to 6. 6 times R equals 54. We don't know what R is yet, right? Assuming we're starting this from scratch. But we can solve this formula for R, or at least start it. We divide by 6. So R times R is 9. And then R times R is R squared. We saw a little bit of this in Unit 5, if you think back to that, working with exponents. And then how do we undo squaring? We take the square root of both sides. And if you try that, if you don't remember the square root of 9, that's okay, but you should be using your calculator if you can't, if you don't recognize it off the bat. I don't either. I don't recognize these things either, especially with the bigger numbers. So I always use my calculator to do my square roots. R is 3. Now, that looks like a good answer. Let's double check. 6 times 3 is 18. 18 times 3, is that 54? Yes, it is. So we did find R, but we had to do some maneuvering to figure out what is in the middle and what is the R number. Okay, let's do another one. Why are they formatted like this? These look so terrible. I don't know why they're coming out like this when they could just write the formula. Okay, so this one is like the first question we did. They want to just know what is the correct sequence formula for this sequence. Now you all have these formulas, but it's a matter of picking the right numbers and putting them into the right places of the formula, right? Interesting. Now we know what the formula should look like for a geometric sequence. A sub n is a1 times r to the n minus 1. So right away, I look at the potential answers they gave us, and I'm going to eliminate 2 of them because they've got n in the wrong spot. I hope you see that. They don't even look like the correct formula, how it's supposed to look. So now it's a matter of finding out what is the correct R for our problem and what is the correct A sub 1 for our problem, for our sequence. Putting those into the right location, and then we can match that up with the answer, find the right nth term formula. I see one person's got an idea in the chat. 2, awesome. Tira and Tatiana, good job, both of you. And thank you for sharing. You found R, right? We're multiplying by 2. So if I just plug that into the formula, here's what we got so far on the right side. There's only one answer that even looks like that has 2 to the n minus 1 as an exponent. Let's just double check. Is A1 4? Yes, it is. The very first term, A1, is 4. So here we go. Here's our formula. And does that match up with option B? Fully, it does. I hope right away we were all able to see this right here. These 2 options, C and D, these are trick questions for sure, because look where the n is. It's not even in the exponent, and we know it has to be our geometric sequence formula. So these guys are bad. Trick question. Or trick answers, right? So when I was looking at this, I was trying to narrow it down. Is it A or B? Which one has the correct R number and which one has the correct A1 number? Any questions on this before we try one more? No. Okay, thanks, Savannah. No one else is saying yes, so no questions. Thanks, Tara. All right, let's look at another. Oh dear. Okay. Let me see if there's more like this. I think I might have overlooked something. I'm sorry, guys. So I want to show you this question, and then we'll be done for today as a group. Your homework, just so we're clear, at this point, we should all have the first 2, not the first 2, arithmetic sequence mastery test and geometric sequence mastery test. So it's actually mastery test number 2 and 3, okay? Those are our homeworks for the week. As well, on Monday, we did notes for the first lesson. Now, for this question, I did not teach you guys this yet, so I didn't realize it was coming up. So my bad. This is another way that we can write geometric sequences. See how this is listed as or series. This is listed as 2 to the 0, 2 to the 1, 2 to the 2. So they're just raising the exponent every time. Now, how do we turn this into a sequence or a series that we're used to working with? One way is just to simply, um, evaluate or simplify the exponents. Anything to the 0 power. I hope you remember back to Unit 5. Every number to the 0 power is always 1. It turns into the number 1. 2 to the 1 would be 2. 2 to the 2 is 4. 2 to the 3 is 2 times 2 times 2, 8. 2 to the 4, 16. And then there's space in the middle where we don't know. So I'm going to put dot, dot, dot. And then we get to 2 to the 9th. What the heck is that? 512. Now, this is a sequence, a geometric sequence. And it looks like each time we're timesing 2. Now, it's not a sequence that goes forever because they stopped it right here. They have a hard cutoff of 2 to the 9. So this is our A1, A2, and so forth. And then at the very end, we have A sub 9, ninth term. And we're not even showing the ones in the middle. Like we didn't show term 5, 6, 7, and 8. That's what's missing with the dot, dot, dot right there. But they're asking us, what is the sum? So we know we're doing our series formula. And we know it's geometric. And now we've turned it from this like adding version of showing the series to the actual sequence right here. I'm going to circle. And we have R and we have A1. So that's all we need to figure out the series. And that is the sum of all these numbers. So here's our series formula. Blank again. Let's practice using it. Let's put in our first term. Good news, first term is 1. 1 minus R. What's R this time? Remember, R is common ratio. Look above. Times 2. Times. Oh, sorry. Thanks. Didn't mean to cut you off. Who was that?
Tiara.
Tiara. It's 2. Good job. Now, what do we put for N? Any ideas how far we're going in our list? Remember, the N stands for like what place in the list we're counting to, because it could go on forever. So N means we're stopping at a certain spot.
So we're stopping at A4?
Okay, stay with me. A4 is right here. So you're right. I see where you got that. Actually, that's A5, isn't it? My bad. A3.
Oh, yeah.
It's kind of messy. It's not your fault. A3, A4, and then this guy would be A5. That's what you were probably looking at, though. But keep going. They actually showed us up here at the beginning that 2 to the 9.
9.
That's our clue, yeah. And we could actually fill in the rest of this where the dot, dot, dots are. But they're kind of telling us at the beginning we're going to the 9th space because of that 2 to the 9th.
Got it.
So wait a second. Sorry, hang on. I'm seeing an error before I'm making it. And this is tricky. And I'm now I feel bad, and I apologize that I didn't do some more formal practice with this like format, how they showed us this problem from the beginning, because we probably should have done that. Let me change my color because I know it's getting messy, and we have just a few minutes, so just stick with me, and then we'll be done for today. Okay. Looking at how we translated these, 2 to the 0 is 1, and that is a 1, right? 2 to the 1 is 2, and that is A2. My point is, I think maybe we're going to the 10th space, not the 9th space. At first, I thought it was going to be the 9th space, 2 to the 9, right? But that's a little misleading because the powers, the exponents that it started with at the very top, it starts at 0. It's not starting at 9. The first number is 2 to the 0 power, right? And that's where that 0 is coming from. And then the 9 is actually the 10th number in the list. Let me try showing this below with some more space. 1, 2, 4, 8, 16. We all see that those are the first 5 terms. And I thought, and probably you guys too, thought that this was the 9th term, 2 to the 9. But this is actually the first 5. What's missing in the ... should be 6, 7, and 8. But I think there's another one in there too to get us up to 5, 12. Yeah, go ahead.
I wanted to point something out too. When I first seen it, I kind of I wasn't supposed to, but I kind of went ahead and I started multiplying every number the long way.
Good, yeah.
So I figured it out, and it was supposed to be 256. Well, that's what I got, but I got 5 numbers. So instead, it was supposed to be 210, 2 to the 10th power.
2 to the 10th power, or the 10th number, I think.
Or yeah, the 10th number, yeah.
Let me do now and basically copy what you did and tell me if I'm on the wrong track here. So you're keeping multiplying and filling in our list, basically. That's good.
Yeah.
So times 2, this is 32, and then 64, and then what is that, 128?
Let me see.
And that should be our 8th number, and then 9th number is 128 times 2, 256. And now here's the issue, guys, folks. We know, looking from the very beginning, 2 to the 9th, we figured that out earlier, was 512. That means we're actually going up to the 10th number. I wanted to make sure we saw that. This is the only problem, I believe, that you could get that is in that weird format. Yes, that's the only one. So I do apologize that I didn't prep you for it better. I'm glad we caught it, though. So we're not doing the 9th place. We're actually doing the 10th place. So n is 10, the first 10 numbers. Things get tricky when we count starting from 0. Basically, we had to add on that extra 1. It's just a little misleading. And then underneath, we have 1 minus a 2 again. Okay, I realize it's time to go. I'm going to finish this. If you guys would like to leave, you can. I've already done attendance. I'm going to finish this, though. And just remember, your homework should be arithmetic sequence series and geometric sequence series. Let's finish this problem. In the parentheses, 2 to the 10th power. We've already done it. 2 to the 10th power is 1024. 1 minus 1024. On the outside, it's just times 1. So usually it's another number, and we would want to keep it there. But I'm going to actually not even write it because it's just timesing by 1. On the bottom, 1 minus 2 is negative 1. Okay, 1 minus 1024. 1 minus 1024 is negative 1023. Now we see we get the canceling. Excuse me. And then if we divide that, it's just 1023. So the sum of these first 10 terms should be 1023. That's adding up all these guys. Okay.